They often put a question in the Senior Mouse Challenge right at the end that is like just a massive step up from even what you've seen throughout the challenge. And for me, this is no exception. This is a fascinating question, but absolutely brutal. Um, let's have a go at it. So find 5 line segments. I think we have to assume that they are respectively 2, 2, 2, 1, and 3. Connect 2 corners of a square as shown in the diagram. What is the shaded area? Well, you look at this and you think, how can I make shapes that I can find the area out of here? You could, for example, join this to this and work out this area. But then I've got this little triangle here where I don't know, I could work out the hypotenuse, but I don't know what's going on here, do I? What am I meant to do? How am I meant to combine it? And that is the wrong path to go down, in fact. What is the correct path to go down is to draw the diagonal in, like that. One other line. I don't think this is obvious at all, but once you've got that, we're actually on our way. And I think here's the key thing, even though you can't see any similar triangles here, when a question looks so difficult that like you don't even know where to begin, look for similar triangles. And actually we have similar triangles now. Um, because we've got vertically opposite angles, so this one and this one are the same. This is a right angle like that. Sorry, I know it's quite small. They both look like I've made right angles, but these two are the same. And therefore it's going to follow that these two are the same. So those are the triangles to focus on. Now I'm going to draw them out over here. So let me call this A, B, C. And because that length is 1 and these are all at right angles, this must actually also be 1. Sorry, not that. The whole length must also be 1. And this length is going to be 2 plus 3. It's going to be 5. Okay, so I can add that one on. That's the one I know. And then I'm going to call this B, D, E. And that length is 2. So in fact, we can see that I have to times by a scale factor of 2 over 5 for the length. Okay, that might come in useful later. Also, the area scale factor would be 4 over 25. Okay, here's the thing, actually. These two are linked together. We know that this length, this small length BD, plus this bigger length AB is going to equal 1, like I indicated here. So I'll call this one X, and then this is going to be 1 minus X. And we're on our way now because I've got, like we said, we've got similar triangles. 5 times 2 over 5 is 2, which means X times 2 over 5 is equal to 1 minus X. And I can work out this length. So 2x is going to be 5 minus 5x. 7x equals 5. There we go. X is equal to 5 over 7. This is 5 over 7, and this is going to be 2 over 7. And if we have that, we can actually work out the hypotenuse of each triangle. So if I focus on this one here, BE, BE is going to be 2 squared. And like, I want to say why I'm doing this actually. Okay, why do I care about that? Because if I get the hypotenuse of this smaller one, BE, then I can also get the hypotenuse of the larger similar triangle, and then I have the diagonal for the whole of the square. And if I have the diagonal for the whole of the square, I can actually work out the sides of the square. If I can work out the sides of the square, I can work out the area of the square. And then I can start thinking about subtracting certain areas to get the shaded area. That's the route, okay? So if you're like, I had no idea where to start, but now I kind of know, pause video and try it out. Still quite a few steps. So 2 squared plus 2 over 7 squared square rooted, which is 4 plus 4 over 49 square rooted. This is actually 196 over 49. We're going to get 200 over 49 square rooted, which is going to be root 100 times root 2 times root 49. It is 10 root 2 over 7. That is that length here. Now we've talked about a scale factor, and I can take my 10 root 2 over 7 and I can times it by oh sorry, it was times by 2 over 5 that way, so it's times by 5 over 2 going that way. And that's going to be 25 root 2 over 7. So then EC is equal to 25 root 2 over 7 plus 10 root 2 over 7. It's going to be 35 root 2 over 7. And this simplifies, amazingly enough, to 5 root 2. Now, what we have is a right angle triangle, 45 degrees either side. This is 5 root 2. It follows that the sides of the square are actually 5 and 5. Because it's x squared plus x squared. If I don't know what, if I just call this x, is equal to 5 root 2 squared. So I then need to, I need to divide by 2. So I'm going to get, sorry, x squared plus x squared is 5 root 2 squared. Yeah, that's fine. So 2x squared. Okay, let me take a bit of time with this. 2x squared is 25 times 2, which is 50. So x squared is 25. So x is 5. What I was trying to say, I've ended up showing it, is that if this is x and this is x, then you always get root 2x here. So you can just divide by root 2 going the other way. Okay, so x is 5. Amazing. That is 5. So we are nearly there, actually. I just want to bring this down, get a bit more space. Okay, so the shaded area is going to equal a half times 5 squared. That is like the whole of the, this side. But then I'm going to need to, so basically I've worked out all of this. Then I'm going to need to add the area of this small triangle, which is going to be a half times BD, which I've forgotten what it was because it was so long ago. 2 over 7. 2 over 7 times 2. And then I'm going to need to minus this rectangle, which is just 2 times 1. And then minus this other similar triangle, which is going to be a half 5 over 7 times 5. Okay, believe it or not, we're nearly there. So it's going to be 25 over 2 plus 2 over 7, because the half and the 2 just cancel, minus 2. We'll leave it like that for now. And then minus 25 over 14. Looking a bit messy. Okay, let's keep going with it though. So actually, I'm going to write 2 as 4 over 2. Okay, so I'm going to get 21 over 2 by combining these. And then 2 over 7 becomes 4 over 14 minus 25 over 14. This is going to be minus 21 over 14, which is 21 over 2. Divide top and bottom by 7 gives me 3 over 2. So 18 over 2, and we are there. Okay, even at that point, it's so easy to make a mistake. Isn't it amazing that we get this whole number out of it? Of course, this question's been set up so that you do, but that's pretty incredible. All right, fair play if you got that. I don't know of any other way of doing this question. Be interested to know how else you could do it, and whether it's simpler or more complicated, but get the diagonal in, find the similar triangles, find the relationships between their lengths, work out the hypotenuse of the diagonal of the square, work out the side length of the square, work out all these areas, subtract them accordingly, and we get this area of 9. Well done.